we've talked about the notes for Hess's law the long way, as well as the notes for Hess's law the short way. So now I'm going to walk you through some practice problems using Hess's law the long way. So we're going to use the thermochemical equations to figure out, so here are our thermochemical equations. We're going to consider this our parent equation. So the first thing that I need to do is identify, do either of the equations shown right there need to be flipped in order for the top equation to match? And so what we can look at is say, well, this top equation right here has 2NO2 as a product, and it has 2NO2 in my parent equation as a reactant. So what I need to do is I need to flip this equation. So I'm going to rewrite that equation over to the right, and then I'm going to show that I have a negative 118.7 kilojoules per mole. And so again, I flip the equation, so then I need to flip the sign. And because this is a positive now, when I flip it, that means it'll be a negative. So then this equation looks like I'm okay because N2O4 is a product, and in my parent equation, N2O4 is also a product. So I'm just going to rewrite it so that I can work on algebraically canceling out my equations. So then I look at, because I didn't flip it, I'm just going to rewrite the value of the heat of formation. So then I'm going to cross out my oxygens because those algebraically cross out, and I'm going to also cross out my nitrogens. So the next step is to look at and see what you can cross out. And then essentially, again, because we're going to try to match that parent equation, I do need to cross off the nitrogens and I do need to cross off the oxygens. So this is going to work because then whatever is left over should match my parent equation. So that's kind of those check marks there telling me I've matched my parent equation. And then the final thing that you need to do is get your total. And so my total change in H is 101.9 kilojoules per mole. So that problem, this next problem is on your own, as is a few more. So let's figure out number 3. I will do number 3 with you. So the first thing that you need to do is figure out which one to flip. And so based on my parent equation, I need to flip the top one because P4 has to be a product. So I'm going to flip the top one, and because I did that, I need to rewrite my heat of formation. It doesn't look like I need to flip the bottom one, so I'm going to rewrite it. And again, because I didn't flip it, I can just write my heat of formation value down. So now, what I am stuck with is that I look like I can cross things out, but my coefficients aren't correct. So what we can do is actually add in coefficient values as long as I also multiply the heat of formation by that same value. And so in order to get it to cross out, or in order to get it to add up to the correct coefficient value to match my parent equation, hopefully everybody sees that I need to add a coefficient of 4 to the bottom equation. And so here I'm showing I've added a coefficient 4 here, 4 there, and then I've also multiplied, or I'm showing that I'm going to multiply that by 4. So now, because of that, I can cross out some values. So I can cross out my 4PCl5. Those two cross out pretty easily. And then this one's a little bit hard because I need 6 chlorines in my product. And it looks like we're not going to be able to make this work. But if I take 4 chlorines away from that 10, then I'm going to be able to drop that down and reduce it to 6. And then everything else just goes straight down, and I've got my equation. And then I finish with my math there, and I'm able to show that my heat of formation and my Hess's law equation is 2,710 kilojoules per mole. So these next 3 are on your own, and the bonus one is hard, so give it your best shot. So in the next video, I'm going to explain how to do Hess's law the short way with those practice problems.